Okay, so we are looking at the 2016 ethanoic acid question. So this question doesn't need to be adapted for first principles. It is going to work the way it is. So we need to figure out what is our data table. So we have attic and we have basement. We've all said that what goes into your basement is going to be the thing that is the whole number. So we have a read through the question and we will be looking for a whole number that would be measured out with a pipette. So if I read down here, it says 25 centimetres cubed of sodium hydroxide. So that's going in my basement. So that is 25 centimetres cubed. The ratio from the equation is 1, and I'm looking for a concentration of sodium hydroxide. There is no concentration, but I have this piece of extra information. So that's going to go down here. So 1.2 grams of NaOH is going to go to 500 centimetres cubed. So I'm going to have to do something with that. I'm looking now for my attic, and I'm looking for a number that isn't a whole number that could be read off a burette. So I'm now looking here, 18.75 grams of my, 18.5 centimetres cubed of my diluted vinegar. There is no concentration in there, and if I read down here, further down, this is going to be my question mark. So, and my ratio for my equation for my ethanoic acid is 1. Any other piece of information in the question? So if I scan through here, I can see 25 centimetres cubed was diluted to 250. So I'm going to use that to get my dilution factor. So 25 centimetres cubed was made to 250. So if I have to figure out my dilution factor, it's 250 over 25, which is equal to 10. So I'm going to use this at some point. So we know from the question that this area here is going to be my weigh-in, but I need to calculate a big M value. So how do I go about doing that? So I have 1.2 grams of NaOH in 500. If I multiply it by 2, I'll have 2.4 grams in a litre. So I can then plug this into my mass triangle to figure out what is my moles. So my 2.4 is going to go up here. NaOH is going to be 23, oxygen is 16, and this is 1. So it's going to be 40. So 2.4 divided by 40 is going to give me, I think I've done that right, 23, 24, 30, 40. Yeah, 2.4 divided by 40 is going to give me 0.06. So this is my way into this question, and as always we are going to be looking at our first principle maths. So we're going to start with our big M value, which is in 1,000. We're going to go down to work out what is the concentration of sodium hydroxide in 1 centimetre cubed. We're going to come up by multiplying by the titration value. We apply our ratio. We then divide by our other titration value to find what's in 1 centimetre cubed. And finally, we go back up by multiplying by 1,000 to turn it into the big M value. Okay, we will definitely be using the mass triangle. So moles, mass, and molar mass. And we will also be having to convert into weight per volume when we are finished. So we now have our weigh in. So as always, I like to say what 0.6 big M means, and that is 0.6 moles in 1,000 centimetres cubed. So we are up here in our little W. We are going to divide this by 1,000. So it's going to give me 6 by 10 to the minus 5 moles in a centimetre cubed of sodium hydroxide. So we're now gone to here. So my next piece of maths is I have to multiply by my titer volume, which in this case is 25 centimetres cubed. So when I do that, I get 1.5 by 10 to the minus 3 moles, and that is in 25 centimetres cubed. So that's a titer volume. I'm going to use my ratio, which is 1:1. So that implies I must have 1.5 by 10 to the minus 3 moles in 18.75 centimetres cubed of my ethanoic acid. That's my other titer volume. So I need to, we've just gone across the top here. applied our ratio. We're now going to find out what is the amount of moles that is in 1.5 by 10 to the minus 3 moles. So we divide by 18.75. So that gives me 8 by 10 to the minus 5 moles in a centimetre cubed. So we're just here at the bottom of our W, and the last bit to finish this off is we are going to multiply it by 1,000. Okay, 0.08 big M. We've all said you just do your first principles, use your mass triangle. So I'm now going to go moles by molar mass. So 0.08 big M by my molar mass of my ethanoic acid. So again, we always show all of our workings out for our examiner. 12, 16, 16 plus 1, and when I put all those together, it's 60. So I multiply 0.08 by 60, and I get 4.8 grams in a litre. So we now go back up and we have a look at our question. It asked, calculate the number of moles of sodium hydroxide in each 25 centimetre cubed portion of sodium hydroxide. So this is this portion right here. So this is now C part 1. And again, if you can't annotate, just at least make sure that you've answered everything. It asks the number of moles of ethanoic acid per centimetre cubed of diluted vinegar. So that is down here. That is a centimetre cubed of our diluted vinegar. So that is C part 2. D part 1 asks us now to find the concentration of original vinegar in firstly moles per litre and then as percent weight per volume. So this here is our diluted vinegar. We now know that we had a dilution factor of 10. So if I multiply 0.6 big M by 10, that's going to give me my concentration in my original vinegar. So when I have done that now, I have answered D part 1. It now asks me to work out it as a percent weight per volume. So this 4.8 again is in our diluted vinegar. So if we now take that and multiply it by our dilution factor, so 4.8 grams in a litre multiplied by 10, that is going to give me 48 grams in a litre, which is my my original vinegar concentration. We have to transfer this to percent weight per volume, which is grams in 1,000 centimetres cubed. So essentially we would take 48 divided by 1,000 to find out what's in 1 and multiply by 100. And when I do that, I'm going to get 4.8 grams in 100 centimetres cubed. And I rewrite it as 4.8% weight per volume. So now this is going to be my D part 2. I've used all of my numbers. I am done.